Have you ever wondered how large retail stores always manage to have what you need and whenever you need it? This is all thanks to the safety stock the store has, and other factors such as the reorder point, the cycle service level, and the fill rate.
The fill rate refers to the fraction of orders made by the customer that are filled from available inventory. For example, if the customer asks for 100 phones and you, as a supplier, deliver 95, your fill rate is 95%. You filled 95% of the order. Fill rate can extend through more than one period. If two orders for 100 phones are made, in the first one you deliver 90 and in the second one 100, your fill rate will be 95% as well. The cycle service level. This is the fraction of replenishment cycles in which the whole customer demand is met. So basically, it's the amount of orders you deliver with a fill rate of 100%. This means we can have a very high fill rate, but if none of the deliveries were complete, the CSL will be 0% nevertheless. Using the previous example, only one of the orders was completed properly, so the CSL is 50%.
Imagine Best Buy being the customer and Dell being the supplier. How can we calculate Best Buy's safety stock with the desired cycle service level? Well, first, we calculate the demand during the lead time period. We do this by multiplying the demand times the lead time. Then, we obtain the standard deviation during the lead time. That is the square root of the lead time times the original standard deviation. The next step is to calculate the safety stock. We can use the standardized normal distribution tables and look for the cycle service level inside the table. And we multiply this value by sigma L. Lastly, we obtain the reorder point, which is safety stock plus DL.
Here we have another type of problem, where we are giving a specific fill rate target, in this case 98%. With the same data from the previous problem, we can solve for the safety stock Best Buy needs in order to accomplish this 98% fill rate. We calculate DL and sigma L as in the previous example, but now we're going to need ESC. Following the formula, ESC equals 1 minus fill rate times Q. Then, we're going to recalculate this value with a formula that will allow us to seek the specific value of the safety stock that we need. This is minus safety stock times 1 minus the normal standardized distribution of SS over sigma L with the cumulative. Then we add sigma L times the normal standardized distribution, but this time the non-cumulative one. This gives us a value that is not 160, so by going to Tools, Goal Seek, we can ask Excel to give us an SS value that can make the ESC 160. And this gives us an SS of 276. This in order to fulfill a 98% fill rate and an ESC of 160. With the safety stock, we can calculate the reorder point, which is safety stock plus DL.